So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, many solar contractors are getting into the battery storage installation business. That's because battery storage and solar go together like peanut butter and jelly. You know, to me, when I think about it, it's like the early days of solar, circa 2000. There's a lot to learn. There's a lot of excitement about the future market. But the equipment is still kind of at the early stages. So it takes a lot to figure these things out, design systems, and do them the right way. The integrated battery storage systems, that's what I'm a big fan of. They're still at an early stage. Nevertheless, many of the systems out there are reliable. And the most important thing, because there's high electric rates now, backup power needs, and some pretty good incentives, businesses and homeowners can save money right now with these systems in many cases, not in all cases. And you also get the benefit of backup power, which is pretty valuable. Now, over the last 20 years or so, I've installed a number of lead-acid battery storage systems, and these were usually for backup power or off-grid applications. And then also, I'm getting more into the business more and more often. About 20% of our customers are putting in battery storage systems using lithium-ion technology. And these systems provide backup power and they reduce the electric rates. Now, the reality is lead-acid batteries are still the most popular battery for off-grid applications. It's just kind of what these off-grid houses have been using for 50 years. They work. They're around. The lead-acid batteries are kind of stable. And the companies that put them in, these off-grid installers, that's kind of what they know. That's their bread and butter. The dilemma is that the lithium-ion battery technology, in my view, is a better technology. Lithium-ion batteries have more energy density, better energy density. That means for a given size of a battery, the lithium-ion batteries are a lot smaller and a lot lighter. The other benefit is lithium-ion batteries can handle more charge and discharge cycles, so they last longer, especially when they're fully discharged. Lead-acid batteries, if you kind of discharge them fully, they have a tendency to die more often. And you can see what happens in your car. Nevertheless, lead-acid batteries are currently cheaper to buy for the same capacity. If you're looking to get a 1 kilowatt-hour set of batteries, lead-acid is going to be cheaper up front, but you're going to be able to get more energy over a lifespan out of the lithium-ion battery. So even on a lifetime basis, if you look at costs, the lithium-ion batteries for most applications are cheaper. So it's clear to me that from a cost standpoint and a performance standpoint, lithium-ion batteries are going to prevail. And the other big advantage is that there's a lot of capacity coming out. Okay, so that's just kind of keep in mind, go with the new technology, lithium-ion, it's better. All right, tip number 2. Beware of what I call a Frankenstein energy storage system equipment design or a battery storage system design. Now, there's nothing wrong with Mary Shelley's monster Frankenstein. However, they're not fully integrated. They may not work exactly like you want. So many of the early battery storage systems were integrated from components from different companies. So the batteries may come from one company. I call that the heart. The inverter, the arms and legs of the system, that's kind of what does the work. That's going to come from another company. You'll have a control system and software, the head, the brains, that's still going to come from another company. The enclosure, that's kind of what the skin of the Frankenstein machine, what the box that's put in. Sometimes that comes from still another company. You may have a charge controller, which still could come from still another company. And all these things have to work together. And the integrated systems that I've seen out there, they did always work. But when there were changes in any of the components or changes in the code requirements or changes in the UL listings or new models, it kind of causes a ripple effect. And then the Frankenstein monster doesn't work really well anymore. This is my analogy, but it's pretty applicable. So the good news is on two fronts. One, there are companies that have done a good job of really integrating industry standard equipment. And even though they may be from several different manufacturers, they've done a pretty good job of integrating it. They're stable, and they've integrated products from big companies. The second thing is that there are a number of systems out there right now from established companies that have put together a more complete, well-integrated system. It's like everything in one box is from one company. That's great. I mean, I can think of a couple of companies that have mostly done that in terms of Enphase, SolarEdge, SMA. Tesla is trying to accomplish that also. So there are companies that are trying to put everything in one box, saying we guarantee it, we test everything, and it works. And that's kind of what you really have to get to. It kind of reminds me of the computer industry. Initially, the PCs, heck, I remember in college, people were kind of putting these PCs together in their dormitory. They're hobbyists, and they were putting together things, buying disk drives and tape drives, and actually they were really tape drives at the time, processors, and soldering these things together and writing their own operating systems. It was really patched together. There was nothing standardized. This hardware was all different. The software was all different. But when Apple and IBM and Microsoft came out with standardized hardware and software, they really reduced cost and improved reliability. I see the exact same thing is going to happen with energy storage systems. These things are going to start coming from companies that have integrated everything in one box, or maybe a few different boxes that fit together, just because that one box could be really heavy. But then it's really going to work, and you have kind of one company to look to make sure that everything works instead of 5 different companies. All right. Tip number 3. Select an energy storage contractor with experience, somebody that's done this before, both either residential or commercial. Integrating the new equipment and communications together, it's not easy. These things are kind of very different than your standard solar power system. Standard solar power system, you'd have an inverter, you have some solar panels, a bunch of electrical work, still kind of complicated. But there's very special skills that are required, additional skills for energy storage systems. Just some examples. Very paperwork intensive to get the incentives. The incentives through the SCHIP program, the book is about an inch thick. It's designed for large commercial and industrial and utility scale systems. Definitely not for somebody that doesn't have a full-time office manager that's really good at pulling these incentive documents together. Another issue with energy storage systems, they require more communications even than standard solar systems. And that's a little bit tricky to put together. There's also hardware and software configuration work that has to be done that's not standard. It's not like just slapping an inverter on the wall, pushing a few buttons, wiring it up, turning it on, and then things are going to start talking. Now, we'll eventually get there. But right now, these energy storage systems are pretty complicated. So what happens for contractors is first few times they do an installation, it's going to take them a long time. They're going to have to figure these things out. They're going to have to train their people. And after going through this so many times, I'm also seeing that the contractors have to train the manufacturers, because the manufacturers haven't done a gazillion installations themselves either. And they haven't designed their processes to make it easy for contractors. Sometimes there's a pretty big burden on contractors. The other thing is, experienced contractors are going to be better at selecting reliable products. Why? Because experienced contractors are experienced. They're in business for a long time. They know what happens when they put in something that's kind of still in beta or it's not really ready for prime time. So they also know from experience which products have the necessary regulatory approvals. And this is kind of a surprise, but some of the components that are in these Frankenstein systems haven't been through all the regulatory approvals. It's complicated going through all these UL listing things. All right. And the other thing is, the experienced contractors have experience working through the inevitable issues with suppliers. Sometimes things aren't right, or with inspectors and authorities that having jurisdiction. So just getting the building permit can be tricky. So I'd say definitely go with an experienced contractor, somebody that's done some of these before, somebody that can give you some reference customers. Okay. Next tip, select a system manufacturer with deep pockets. And basically I'm saying find a company that's been in business a long time, that's put their name on the equipment. That way you've got a better chance of the equipment lasting a long time. Now, the inverters that go into these systems, typically they're designed to last 20 plus years. In my experience, the major manufacturers do have equipment that's going to last that long. The batteries mostly are guaranteed to last 10 or more years. You know what? lifespan, this guaranteed lifespan, it's somewhat arbitrary because the rebate authorities sometimes demand a 10-year warranty. There's no real logic behind it. They just say, we want everything to last 10 years so our ratepayers aren't going to get screwed. So the manufacturers have to put a 10-year warranty on it, even though the product, might have only been on the market for a year, and the battery technology may have only been in manufacturing for 5 years. So getting it from buying a system from a company that's got a good background and deep pockets is going to give you some advantage there. So these big manufacturers, they have two big advantages. First, much more likely to be around 10 more years if they've been around for 10, 20, 30, or 50 years. And second, they generally have a better track record for releasing stable, reliable, what I call non-beta products, something that's really ready for prime time. You'll be surprised at the number of companies offering battery systems that are not much more than prototypes. And it's expensive and time-consuming to get all the necessary regulatory approvals and get these things working exactly right. Because a customer just wants something that's going to work, and an experienced contractor wants to install it and have a happy customer. They can't go back and patch things every month. Diving right into the next suggestion for successful energy storage implementations. Remember, communications is important and complicated. I'm not just talking about our failure to communicate sometimes. I'm talking about the data communications that has to go on between the components and to central server and to the company that's maintaining the system like us and to the customer. So for most energy storage systems, you're going to need 2 or 3 data communication lines. There's going to be communications between the inverter and the central server, and that's through the internet, and that's basically how the installer can monitor the system, and that's also how the business or the homeowner can monitor the system. You're also going to need communications between an electric meter that's installed on the system to measure the building consumption and the inverter, which is then going to communicate through the internet to the central server. In many cases, you also need communications to the battery system. So, it's lots of electricians are good at putting in thick number 10, number 8, number 6 wire, but a lot of these communications require installations of Cat5 cable, and it's a little bit, you need different technology. It's a little different. And then you're going to have software on the other side of it. We'll get to that in a minute. What we're also experiencing is there's gadgets that are used to monitor the building power usage, and these are called current transducers, and they generally go around the incoming power lines. Well, what we're finding is that most of the current transducers that are being sold don't work on all the systems, don't work on all the incoming power lines, all the service panels. So we have to sometimes use this gadget called the Rogowski coil. It's kind of crazy. It's just a totally different technology. It's a magnetic loop instead of a fixed current transducer. But what we're finding is rather than get to a job, get all the electrical panel removed and start putting the equipment in and find out, boy, we can't get the current transducer in, or it's the wrong type of current transducer, we have to use something that's a little bit more expensive, but then it means that we can get that installation done a lot faster. So that's kind of, these are little surprises that come up that the manufacturers really aren't that familiar with, that installers, contractors like Cinnamon Energy Systems are. All right, setting up these communications is complicated. These things don't self-configure themselves. Sometimes you got to push a lot of little buttons and go through crazy menus on little LCD displays. It takes time. And it also limits the system configuration. You can't kind of configure every system to do every single thing you want. And I'm not just talking about the software configuration. I'm talking about some of the physical configuration of where all the equipment goes. For example, what we're finding is the inverter and the battery and the meter must be pretty close to the main electrical panel. You can't separate these things. So unlike ordinary solar systems where we could put an inverter on a ground mount far away from where the electrical panel is, you really can't do that with these energy storage systems, at least the ones that are fully integrated. That's because you have to have communication among all the equipment, and these communication distances are limited. All right, number 6, expect delays on your energy storage system installation. This is not the kind of thing that a solar contractor can kind of bang out for a home in a day, or a commercial contractor can bang out a job in a week. The installations are more complicated. Yes, we still have to put in the solar panels, the inverter, and the wiring, but there's a lot more components that have to be put in, and these components have to be configured together. So it's basically the same as solar. Plus you have a specialized inverter You have control systems, you have batteries, you have a different kind of enclosure, and there's a lot more complication with the interconnection and the utility coordination. So, the reality is, and we've talked about this a lot, but utilities really don't want homeowners or commercial building owners to install their own storage and solar. That's something they want to do at the central office or at a substation. So they make it a little bit more difficult, and sometimes they even prevent it for some kind of crazy regulations for you to do. So it's tricky to go through, navigate that process. Now, also tricky to get the permitting, because many jurisdictions, many cities and towns haven't seen these systems before. So they're going to ask a lot of questions. And finally, when you're going to get everything ready to go, then you have the issue of configuring everything, both from a hardware and software standpoint. Okay, next tip, permitting. And we talked about this before, but permitting in some authorities having jurisdictions, some cities and towns, is going to be very time consuming. Same as solar, but way worse. So the reality is these cities are seeing a battery storage system for the first time. They're seeing systems from new manufacturers that they're not familiar with. And the building officials have a lot of questions. And you know what? Their concerns are justified. Their biggest concern, biggest concern should be about safety, making sure nobody's going to get hurt, that no fire is going to occur, that there's the proper safety equipment in place. And they're going to kind of want to make sure that these energy storage systems meet those requirements. The inspectors, even after you get the permit, the inspectors are generally not well trained on these systems because they haven't seen them before. I mean, pretty much every system we're putting in, generally this is one of the first or among the first systems that these inspectors have seen. So it takes a little bit of time to train them. Now, the other thing is the authorities having jurisdictions, the cities and towns, they may want to make some changes. Sometimes they're arbitrary. Sometimes they're wrong. I kind of try and help them out going through that decision-making process. Sometimes they raise a lot of good questions. And one of the issues that comes up with these new energy storage systems is some of the equipment or some of the components inside the boxes may not be properly UL listed for the application in which it's being used. And that's one of the other reasons why I think it's always good to go with a big manufacturer, especially at this early stage of the market, because the big manufacturers would have dotted all the I's and crossed all the T's to make sure that everything's going in properly. Okay. All right, next issue, number 8. Soft costs are a killer. Now, the soft cost issue is something that solar contractors kind of have learned to hate. These are non-hardware costs. So if you're looking at an installation, let's just talk about a residential battery storage installation, it might cost $35,000 to put in a whole system. But guess what? The equipment might only cost $15,000. Why does it cost so much to put the rest in? Well, really, really complicated for the contractor to go through all the issues involved in making sure some things are done right. So all these extra delays and uncertainties that the contractors experience, both for residential and commercial, add to the costs. I mean, another example is financing costs. Sometimes the financiers aren't familiar with these energy storage systems, so they're going to ask a lot more questions. They may actually charge a higher interest rate. The equipment specifications and designs, they evolve, they change, they're being improved. There's a new and improved system. Well, that's going to mean that you have longer installation timeframes because these new components have to be tested and kind of built into the equipment design. The rebates. Boy, I'm a big fan of rebates. I used to say that I've never seen a rebate that I didn't like. It's great to have these rebates, these incentives, like California's self-generation incentive program. But they're really complicated. In particular, the SCHIP program's flawed for small systems. The guidebook's an inch thick. It was designed for $1 million commercial and utility scale systems, not $10,000 residential or $100,000 small commercial systems. So contractors have a ton of paperwork to go through. And then there's a lot of hoops to jump through just to get the systems integrated. And the bigger the system, the more complicated that is. All right. Tip number 9, new equipment and new vendors, many of which will fail. So beware of getting stuck with orphaned equipment. Happens in every new market, happens with cars, happens with everything. There's some companies really survive for a long time. Some companies come out with a great product on the market, and then they're just may not succeed. So the majority of vendors out there are going to disappear. So you're going to end up with orphan equipment if you're really at the bleeding edge of technology. It happened in the solar industry a lot. Now, the good news about the solar industry is the old solar panels almost always kept working. But I did have, back in 2000, 2001, 2002, also, experience with orphan inverters, inverter companies that came out with products. They basically worked, but not as reliable as some of the other more established vendors that we have right now, like SMA and SolarEdge and Enphase. So you kind of have to keep your eye on these companies. And, if you really want to go with something that's early bleeding edge, just be careful. Same thing's going to happen with energy storage systems. I think the biggest battery manufacturers like Samsung, Panasonic, LG, they'll be around. The biggest inverter companies are going to be around. But there's a lot of software companies out there, and there are many of which are startups. So I'd advise making sure that you get a system that's composed mostly from big companies that you kind of hang your hat on. Okay, last tip. Homeowners value backup power. This was kind of a surprise to me because I expected the energy storage systems for consumers to provide a clear economic benefit, time shifting and rate arbitrage. But the reality is the delta, the difference between peak and off-peak charges in California is only 10 cents at most on standard rates. And if you have a battery that's going to have 27.4 megawatt hours, and you kind of do this really rough calculation of the maximum savings, that means the maximum that you can save on that battery over its 10-year lifetime is $2,740. Now, on different electric rates where you have a much bigger difference, like the EV rate, there's a 33-cent difference on the EV rate. And in that case, you can save $9,000 on a battery backup system. And that's where it kind of makes sense. And that's what we're emphasizing our customers to take advantage of. So you kind of watch out, because if you're looking at an economic advantage and you get something that has an 11-year payback on batteries that are only guaranteed for 10 years, guess what? You're going to have a dilemma. But it is a pleasant surprise to me that customers really need and value backup power. And there are security benefits there because we depend on electricity more and the grids become unreliable. Nevertheless, these economics are going to continue to get better. All right, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.